Hello, welcome to WPF Converters.
There are times when the data coming out of the view or the view model or the controller is not exactly what we need in terms of displaying that data. So for those cases, we have one last chance to manipulate the data in such a way that it's appropriate for the view part of our code. This mechanism is known as a value converter. So let's take a look at an example of a value converter to see how they work and how to construct one. So we'll start with the temperature conversion demonstration code. Rather than look at the code in this, what I'm going to do is I'm going to add to it. Right click on temperature conversion and select add class. And I'm going to call this dummy converter. So here's the dummy converter class, and I'm going to make a couple of modifications to this. The first thing I want to do is I want to implement the iValueConverter interface. So I'll pick the appropriate using directive, and once I've got that in there, right click on iValueConverter, select Quick Actions and Refactoring, Implement Interface. And as you can see, the interface iValueConverter mandates that the class that implements it has a convert and a convert back method. So this was a demonstration about how you can create the class, state that it's going to implement a specific interface, and get Visual Studio to build the appropriate methods for you to add the code to. I don't need this converter, so I'm going to go ahead and delete this at this point and look at one I've already built. So here we see Celsius to Fahrenheit converter, which, as you see, implements the iValueConverter interface that was built just as we saw before. So let's start with the convert method. So as you can see here, I've got some code that converts a double value in some way, and as you can probably guess, it converts a Celsius number into a Fahrenheit number. But let's just walk through it real quick. What we're doing here is we're checking to see whether or not the value parameter here can be converted into a double, and if that double is not a number. In other words, it's bad data. So if that's the case, then I'm going to return this string indicating that whatever data I got could not be successfully manipulated. Otherwise, I'm going to go ahead and apply the standard mathematical definition to converting a Celsius temperature value into a Fahrenheit value. Now let's see how that plays into our system. So we start with the model class, which in this case is temperature source. So here's our model class, and it will be a publishing model class. In other words, it implements iNotifyPropertyChanged, and it has the standard code that any class would have that indicates that it publishes the fact that its property values change. Of course, as you would expect, it provides a temperature value in degrees Celsius. So from there, we move on to our view model, which in this case is temperature view model. And as you can see, we have an auto-implemented property that passes through the temperature source or the model object to our view. So let's take a look at the view. So we start with the code behind of the view application. And the first thing we see is that we have a view model, in this case called Celsius temperature. So we create that object, and of course in the constructor for this class, for this main window class, we assign that object to the data context property of the window. And that allows the binding to take place. So that's where binding is going to look for the data in the data context object, which in this case is connected with our view model. All right, so we have a number of buttons associated with this application, and what we're going to be doing is setting the model current property to one of its various constants. They all three do the same thing, just with different numbers. From here, we move on to the designer of this WPF application. And as you can see in the designer, we have various buttons for setting the temperature to a particular value, and then we have some output. In this case, a degrees Celsius and a degrees Fahrenheit. So let's take a look at the bound controls of this particular application in the XAML file. And to start off with, we have a text block that is going to represent our Celsius, or in this case our native degree number, so it's not going to require conversion. So it will be bound. So here's our text block, and then the text property that is bound, as you can see here, to source.current, which is of course the name of the property inside of the model object. Notice also the use of the fallback value attribute. Here it's set to 000. This is useful with binding for a couple of reasons. One, it puts a value on the property at design time so you can sort of see what things look like when there is no data. And two, if binding does fail for some reason, then that's the value that the text property will have. All right, so let's continue forward to the text block that actually requires the converter. And you see it here, text block degrees Fahrenheit. It is pretty much the same as degrees Celsius, except, let's take a look at the binding. Inside of binding we have an attribute converter, and that's set equal to static resource Celsius to Fahrenheit converter. So you may recall that Celsius to Fahrenheit converter was the name of our class that implemented iValue converter, and it also is using the fallback. The point here is that both of these text fields are bound to the same property. In this case it's read as source.current, which of course is the property inside of the model object. However, they are being displayed differently because one is going through the converter. In other words, it's taking that decimal number, which represents a number of degrees Celsius, and it's converting it into a Fahrenheit number, which will then be displayed in the window. In order for our main window class to have access to the Celsius to Fahrenheit converter, it has to be declared as a resource in the XAML file. So going up to the top of the XAML file, we see here that the tag window resources has been added, and then inside of that we have local and then the name of the converter, which is Celsius to Fahrenheit converter, and then the name that it will be using in the XAML file when it's actually called out as a converter. So let's see what that looks like when it runs. So we see that we start off with not a number, degrees Celsius, so that's the native value from the temperature sensor from the model object. And I click on freezing, and it sets it to 0 degrees Celsius, but the way that's displayed in Fahrenheit is 32, and the same for the other two. So 37 Celsius is 98.6 Fahrenheit, and boiling 100 Celsius is 212 Fahrenheit. Now occasionally we need to have the user interface, which is to say the view, inform the model class. In other words, instead of having the model class tell us what its property value is, we want to be able to get value from the view and have it change the value in the model object. And we can see this in our code. If we go back to the designer, we have a text box here, and it is also connected to the converter in the same way that the text blocks were earlier. But because this is a text box, and not only displays a value to the human user, but also might want to take a value from the human user, we're going to use the reverse of convert in the converter. So let's take a look at that code, and this is where convert back would be called. So convert back takes that string from the text box and attempts to convert it into a number, and that's what you see here, and that would be a degree Fahrenheit, and then of course we do the appropriate mathematical manipulation on that value to turn it from a Fahrenheit number into a Celsius number. So let's take a look at what that looks like in practice. So you see it's up here. It says force Fahrenheit datum into sensor. So what we can do is we can put a Fahrenheit value here. Let's say, for example, 451, and then force that datum into the sensor, like so. So 451 degrees Fahrenheit, and as you can see, because we're doing a convert back, the degree Celsius is 232.7, etc. Now, having said that, it is often the case that we're not doing a convert back with our converters, and in that case it's fine to allow your convert back method to remain unimplemented. In other words, you can leave it as Visual Studio created the stub. Now here's a couple of bonus facts about data binding and displaying data. The first is that if you have a text property, let's say our text block degrees Celsius, and you want to control the display of this text to some extent, but you don't actually need a converter, what you can do is you can add a string format attribute. So what this allows you to do is not to change the data, but just affect how the data is displayed. In this case, I want no more than 2 digits after the decimal point. Now you'll notice the use of the double curly brackets here. That's because otherwise the parser for XAML gets kind of confused because there's too many brackets. So if all you have is one thing inside of your curly braces for your string format parameter, you'll need an extra set of curly braces here, an empty set, to sort of alert the XAML parser about what you're doing. If, on the other hand, you had some additional information in there, let's just put some characters around that, then you don't need that empty set of brackets. But in my case, I do. And so that will control that Celsius display without actually doing a conversion on it. It's just changing the format of it. Now, you can actually do that as well with a converter, so you could include this with the text block that has the converter attached to it as well. So both of those will work. So now if we run our code and force 451 into the model object, you'll see now it's degrees Celsius instead of a whole bunch of sevens, just has 0.78. And because I also attached that to the degrees Fahrenheit, I'm getting the 2 decimal points as well. Now you may have noticed that I use that string format on something that has a text property. If you're binding to something that has a content property, like let's say a label or a button, there is no string format. You have to do it slightly differently. Let's take a look at the example we used before with merge coin boxes and take a look at the XAML there. And here, for example, is a label, and that label is bound to, but if you try to put string format into the value of the binding, you'll find that it won't work. It's not defined for labels. So what you need instead is an attribute content string format, which goes outside of the binding data. And there you see that same sort of pattern. In this case, I wanted the value to be printed out as a currency value. And so again, I needed that empty set of brackets because I didn't have any other data in my format. Bonus fact number 2 is about debugging. So going back to our example with the text box, here we have a binding to the text property using source.current. And let's just misspell current. It can be kind of frustrating to debug this sort of stuff because if you run the code, you actually don't see anything here where the data is missing. It doesn't give you any sort of error. It just simply doesn't do the binding. So one of the ways that we can try to figure out what happened here is you go to the output window. So if it's not already up, you go to View, Output. And so here we see the message that indicates that it could not find the property called current. So that'll give you a little bit of help. The other thing you can do is you can attach a converter. Unfortunately, it doesn't really help to run this through the debugger because the debugger has no place to stop. However, that's one of the nice things about converters. If you add a converter, now in this case we already have a converter, but let's say that we didn't have a converter for this one, you can add a dummy converter and just put some code in there that you can put a breakpoint on, and when the binding takes place, if you run it through the debugger, you'll be able to at least step through the code and see what the values are as the code is running. So between those two things, the output window and the dummy converter, or just the regular converter if you have one, you might find it a little bit easier to debug your bindings.
That's WPF converters. Thanks for watching.